Okay, in this video we're going to conclude with the secant and cosecant functions. Both of these functions are the reciprocal functions to cosine and sine, respectively. So we're going to use those two graphs, the sine and cosine, to help us graph the secant and the cosecant. So again, the first thing we're going to do is take whatever graph we've been given and trade it out with its reciprocal partner. For example, if we're given the secant, we would trade it out for cosine and lightly graph the cosine curve with all its transformations. Once we've graphed that cosine curve, we would draw the asymptotes where the sine or cosine functions are equal to 0, because that's where the secant function would be undefined. And then finally we would sketch the reciprocal graph. And I'll tell you right now that the reciprocal graph for both of these functions take on the shape of a familiar graph, the parabola, and you'll see why in just a second. So let's take a look at the first example. Again, we're going to trade out the sine, the cosecant for sine, and we're going to lightly sketch this graph. So let's take a look at some of the characteristics of our sine curve. First of all, its amplitude will equal 2, and the period of this graph will be 2 pi over b, which is 2 pi over 2, and it will have a vertical shift down 1 unit. So let's set up the basic building blocks of this graph. There is the vertical shift that's been lowered 1 unit. I am going to rewrite these points, changing them out so we can see the graph a little bit better. Next, I'm going to graph the sine curve. So again, this is just one cycle of it. And where we have zeros of the function, as you can see right here, and here, and here, those are the zeros of this particular function because those are the ones that are landing on that vertical or that horizontal bar. That's where we're going to put the asymptotes. Again, this is where the cosecant would be undefined. Next, the rest of the graph is the part that I was sharing with you earlier. They look more like parabolas. Let me just explain the reason why this shape takes place. Being that sine is the reciprocal function, we can see that as the sine curve approaches a lower number, or that bar which would be the 0, then reciprocals would be doing just the opposite. So for example, say that's 1 over 100 right there towards that asymptote. The reciprocal of that would be 100, so the graph is actually blossoming into infinity. In like manner, the same thing is going on down here, and they do share the max and min points, so don't create a gap between the two graphs. They actually do physically touch at their max and mins. Now, if I wanted to extend the cycle of this graph, I could, and place more asymptotes in, and again do another cycle of the curve. The period for the cosecant is also 2 pi, simply because we have two branches of it. We have this upper branch and we have the lower branch, so we'd count that as the full curve. Now let's take a look at the second graph, which is secant. So again, all I'm going to do is trade out the secant for cosine. And let's write down some of this information. We have an amplitude of 1. The period is 2 pi over b. And therefore the period will equal pi. And the phase shift this time is going to be to the left pi units. And there is also a vertical shift down 1. So let's once again set up the building blocks of this curve. So again, I'm going to just rewrite the points on the x-axis and set up the vertical shift, lowering of the horizontal bar by 1 unit, and sketching the sine curve as it starts over at negative pi because this graph has that shift. And you can see that in honesty it's the normal sine curve because again it repeats itself here at this at the origin actually. So again, our duty is to set up the asymptotes, and then we can sketch the branches to this curve. Now notice the similarities between each of these equations. They're very similar. Really the only difference is the placement of the asymptotes, and but the shape of the curves are identical. So with that being said, that pretty much concludes how to graph the secant and the cosecant curves. We will just take a look at the summary of all 6 curves, and you can see that the domain and the range of the secant and cosecant, you may want to take a look at that. We do have that breaking point between the two, so there's actually empty space in between the amplitudes. So again, make note of that and understand that they do connect with the sine and cosine curves respectively, and so therefore we would include those endpoints. Good luck, and we'll see you in class.